In this online lecture, we're going to discuss the formation of peroxides, and it's very important that we understand this because peroxides are going to play a very important role later on. We're going to see that they make great radical initiators. So for now, we're just learning about how to create them in the first place. So our first key point is number one, peroxides can be formed by simply reacting ethers with a radical and an oxygen. And like I said before, number two here, peroxides can act as radical initiators to generate radical chain reactions. So let's look at a peroxide right here. Here's one way to think of one, ROOR. You can also have something like this, ROOH. The defining characteristic here of the peroxide is simply this O singly bonded to another O bond here. And what's unique about these peroxides is simply that bond between that oxygen is kind of weak, which means it can homolytically cleave very easily and in the process create two radicals. We saw in previous online lectures how radicals are formed in initiation reactions and then later on create propagation reactions. So let's see how to make peroxides first. Basically what we start with, like we said before, is some kind of radical and an ether, which you see here on the left. There's a lot of options for the radical, so we're being just generic here by just saying a radical. The first step of the mechanism looks like this. The one electron from the radical moves this way, and focus on that CH bond there in the ether. One of the electrons in this bond meets up with that electron, and the other electron in the CH bond simply jumps up on top of this carbon right here. Notice the result of these moves would be this structure right here. And as a side product, you're going to get HA. Notice what we've accomplished here is turned our ether into a radical. And just so we know what went where, this hydrogen on the ether becomes this hydrogen in the HA. Now, after this step, we take our newly formed ether radical molecule here, and we simply react it with O2. And here's the mechanism. The one electron here moves this way, and one of the electrons from O2 meets up with him. The result of this movement right here is this molecule here. This thing is simply termed a peroxide radical. However, we're not done yet. We then take this peroxide radical and we react it with another ether in solution, the same one that we started out with. But this time, one of the electrons on the oxygen moves this way and meets up with one of the electrons in the CH bond like this. And the other electron in the CH bond simply jumps on top of this carbon, just like what happened before to this ether. However, we get this result this time. We actually end up getting our peroxide. Notice the CH in our peroxide here. That CH is above connected to an oxygen, and that oxygen is connected to another oxygen that then has a hydrogen. That is our peroxide right there. But one more thing let's notice here, the side product of this reaction would be this right here. Notice this is the same intermediate we saw last time the ether react. And all I'm trying to point out here is the reaction repeats itself at this point. Again, meaning that the radical that we get here reacts simply with another O2 in this fashion, and we end up with this peroxide radical. And then that peroxide radical in turn turns into just the plain peroxide. So this is all that we're trying to learn here. Key points. Key point number one. Peroxides, the way we form them is simply by reacting ethers with a radical and oxygen, not just oxygen by itself, but O2 oxygen. And key point number two here, peroxides can act as radical initiators to generate radical chain reactions. We'll learn these in other online lectures.